Hello and welcome back, everyone. I know you are already being busy with a lot of history facts to remember, but in this video, we're going to start with the components of robots. We're going to see what all components are used to make a robot, and in general, what all components you should know when you want to make a robot. Now, in this module or in this chapter in particular, we are introducing or doing an introduction to the robotics. So I'm going to talk about just the component section and a little more on this chapter, and we're going to see how you can, make a robot with the help of these components and how you can find which all components are being used. Without any further ado, let's get into it. Okay, so we are back with our presentation screen and we have introduction to robotics. Okay, let's move ahead and see the components of robots. Okay, let's break it down first. Okay, so robots are made of several key components that work together to enable functionality. Very important point to see over here is that robots are a bunch of components or group of components which work together to make a robot move. And this means that you're going to have electronics, you're going to have mechanical components, you're going to have software elements, which are going to make sure that everything happens at the right time and with the right purpose. Okay. So let's start by a couple of other things. Let's break it down and see what we usually see. The main component of robots include mechanical structure, power source, sensors, and actuators. Now, don't worry if you don't know what an actuator is. Actuator is nothing but any sort of device or a mechanical device which can help you actuate or move things. Okay, that's what an actuator is. It can be a motor, it can be a linear actuator, which means it can push things, or it can be other mechanical motion-based device as well. Okay. Power source is, of course, the power supply. It can be a battery, it can be electrical supply, or it can be anything like that. Mechanical structure, of course, the way the robot is looking or the mechanical appearance of the robot. Sensors, which are used for sensing or capturing the data, and a couple of other things. Look, let's start with the mechanical parts of the robot. The mechanical parts of the robot include frame, joint, and end effector. Okay, so you have a frame, which is going to be the body. Okay, you have the joints, which are going to be the one which are going to help you move or rotate. As the end effector, which means the gripper, or it can be, anything which is going to grip or hold, that's going to be the end effector. The frame is the basic structure of the robot and provides support for other components, which means it's going to hold the components and it's going to make sure that the robot structure is intact, and it's going to support the other components as well. So, just to make sure that other components don't lose apart or don't fall, we need to have the structure. Then you have the joints, which are connections between the different parts of the robot, which allow for movement. Now, what does this mean? This means that the mechanical parts or the mechanical structure is going to be robust enough so the robot can move, robot can, see things, and robot can, inspect more and more things. So the joints are the connection between the different parts of the robot that allow for movement. Now, a joint can be anywhere. It can be even in the arm of the robot, or it can be in the leg of the robot, or it can be even in a lid of the robot as well. Then you have end effectors. For a lot of you, this might be a very new term. End effectors are generally referred to grippers. So you see like some of the robots have this gripper which grips thing. These grippers are known as end effector. Okay, there can multiple kind of grippers, of course. There can be an end effector or the end of the robotic arm, which can have a welding torch, which can have a suction cup, which can have a torch, which can have any sort of cutting tool as well. And this can vary in different applications. So end effector are the tools or the devices that are attached to the robot and that allow to interact with the environment. Okay, the main important thing over here is to understand that it is going to interact with the environment. Then you have sensors in the robots. Let's talk about a little sensors this time. Okay, now what do we mean by sensors? So sensors are usually used to provide robot with information about the environment. Okay, this is a very hot one. Okay, so sensors. Okay, you might have seen, you might have heard, you might have known about sensors from a very long time. I'm going to break it down and tell you what sensors are in a very simple format. Now, any physical, environment-based entity, okay, be it anything, be it water, be it air, be it touch, okay, anything which has happened to a physical human being or physical presence of anything, it needs to be understood in a digital format. Okay, a sensor does exactly the same thing. It is not really any complicated thing. Rather, it's a very simple structure which helps you convert a physical interaction into a digital interaction. That's it. Okay. If you are touching something, then you need a touch sensor, which is going to convert your physical touch into a digital sensor so that the robot knows that you are touching it over here. If there is a rain, then you use a rain sensor, which is going to tell the robot or the machine that there is rain happening. So it's going to take actions accordingly. Okay. And so on and so forth. And then then you have proximity sensors that is also mentioned on the BPD. Proximity sensors basically means, when something is very close to the object, then you know that the object is in proximity of that thing. So it knows that, there is something which is close by. So the proximity sensor sends signal, and then it knows that there's something. Then you have vision sensors, cameras, of course, which are helpful. Force sensor to understand the impact. Okay. If you're hitting something, how much force did you hit it with? And things like those. So all of these things put into place are known as sensors in a robot. And sensors play a vital role when we talk about, understanding and building concepts in different formats, in different, methodologies, and in different, lifestyle parts. And that's kind of the main thing that we're going to talk about here. Then you have proximity sensor that detects the presence of an object in the environment, which is essentially what I told you. If there's an object which is there, you might have seen a proximity sensor when you see a reverse parking sensor of a car. You can see that the car is beeping all the time, and the beep increases if the car is becoming very close. That happens because of the proximity sensor. Proximity sensor will tell you if the vehicle or the object is close by, and then you can know and take actions accordingly. Then you have vision sensors. Now, vision sensors are just a little complicated term for cameras. Okay, it basically allows them to analyze the surroundings. Of course, there are different kinds of cameras. That's why we generalize them with vision sensor as a single term. And then you have force sensors, which are essentially allowed to robot to detect and measure forces. This can be any force. It can be a lifting force, or it can be a throwing force, or it can be anything which is around you. Now, this system in itself is quite an important aspect of how robot understands what is happening in the environment. Okay, if you want to see or if you want to feel something, you have your skin, you have your eyes, and these are all our sensors. Similarly, robot needs sensors to analyze what is happening in the surroundings as well. Okay, let's talk on to the next part, which is actuators. Okay, actuators are very interesting. Personally, I love actuators as it's one of the most favorite topic of mine. Okay, so actuators are used to control the movement of the robot. Now, we have already understood how we're going to understand the environment. Now we're going to actuate according to the environment. Okay, let's say, hypothetically speaking, if the robot understood that there is rain happening, now the robot needs to hide away. How is that going to happen? That's going to happen with the help of actuators. Okay, an actuator allows the robot to move from one point to the other point. It's going to allow the robot to take a decision accordingly. Okay, and an actuator, of course, it's not going to directly take a decision. The controller takes a decision, but actuator are the one by which a robot can move itself automatically from one place to another. Okay, it doesn't really need to depend on anything else if it has an actuator which can help it to move. Of course, you need to have enough actuators so that they can move the robot. But if you have enough actuators, then you're good to go. So actuators are used to control the movement of the robot, as the definition says. There are several types of actuators in use in the robot, including motors, pneumatic actuators, and hydraulic actuators. Now, pneumatic and hydraulic are nothing but pneumatic means air, hydraulic means oil. Okay, so if the motion is happening because of the air, that's a pneumatic actuator. If the movement is happening because of the oil, then it's a hydraulic actuator. Let's talk a little more. Motors are used to provide a rotary or linear motion to the robot. Pneumatic actuator is used for compressed air to provide the force and motion to the robot. Now, motors are one of the most popular actuators you see in a robot. Okay, you will see motors everywhere. Now, these are the same motors that help electric cars also move ahead. And the main idea over here is that the motor is going to, give you either a rotation motion or a linear motion. How can you say it's a linear motion? If you see a wheel of a car, it's basically rotating, but it's going ahead in one direction. So we are converting the rotary motion into a linear motion, and that's what we say that you have a linear to rotary converter. Then you have hydraulic actuators used for hydraulic fluid and provide force and motion to the robot. So what happens is that your entire action or your entire motion that happens is because of a hydraulic actuator. Now, what does it mean? It means that hydraulic actuators are used for with fluids, and they have a very good principle that you can use a hydraulic actuator when you want to lift extremely heavyweight stuff with a very small amount of area, and hydraulic actuators are pretty good in that, actually. So I must recommend that. Now we have power source of robot. Now, when you think about a power source in general, I'm pretty sure you're able to think for a lot of things. It can be battery, it can be power plugs, the one where you put in your sockets, or it can be any hydrogen cell as well. Let's say now there can be very different types of power sources. Robots require power source to operate. Of course, you need power. There are several type of power sources used in robot, including batteries, a fuel cell, which is also known as hydrogen cell as well, power cords, which means power adapters or direct plug adapters or something, and of course you can add solar panel and everything. Those are all in the same category. But the main idea over here is that you need a power source which is consistent, which means it's stable. Okay, it's not fluctuating, and it's also good enough that it can power the entire machine. Okay, very important. Batteries are commonly used in mobile robot because they provide portability and flexibility. Absolutely. You take an example of a phone. Okay, if there was no battery inside the phone, imagine using it with the like power connected all the time. That's such a difficult task. That's why batteries provide the flexibility that you need when you want to move or with the machine itself. Fuel cell are used in some application because they can provide long run in times and great power output. Now, fuel cell or hydrogen cell are usually the ones which can run for a very long time. But one of the thing that is a problem is the fact that you need to make sure that fuel cells are in a very stabilized condition. If they are not in a stabilized condition, then they can explode, and that's a very big problem. Power modules are used in stationary robots because they can provide a reliable and consistent source of power. As I mentioned, consistent source of power is very important. If the power source is fluctuating, then it's not going to work at all. Okay, very important for you to remember as well. Conclusion. Okay, let's see what we want to conclude. In conclusion, the main components of the robots are mechanical structure, power source, sensors, and actuators. The mechanical structure includes the frame, joint, and the end effector, while sensors provide the robot with information about its environment. Yeah, you see what we're trying to do over here? We're actually trying to capture the environment using sensors. Then we're going to act according to the controller, and we are acting because of the help of actuators. Okay, so the sensors are capturing the data, actuators are performing the task, and actually the controller is helping to think, or the robot to think essentially. Okay, and these all components make a good robot. Okay, and power source, of course, a good power source is going to make sure that the robot keeps on running even if there's a problem, and that's very important as well. And then we have actuators are used for controlling the movement of the robot. This is a recap essentially. And understanding these elements of the robot is essential while designing and building effective robotic system, of course. And that's it. We are done with with this chapter actually. Yeah. So I hope you understood. Let me come back to my main camera. Okay. So I hope you understood what elements of a robots are. Essentially speaking, a power supply, a controller, which is not a controller we have not really mentioned here, but controller will come in the future. So right now, for now, essentially you have a power supply, you have an actuator, and you also have a sensor. Okay, so three things which are pretty much the important aspect. The controller is optional because not every robot is autonomous robot. Sometimes we control the robot with our own brain or human brain. So in that case, we don't really add a controller all the time. That's why you don't see controller all the time in different PPT or different presentation or different videos as well. But that's it for today. I hope you had great fun understanding today's lecture. I'll see you all in the next one. Till then, happy learning and peace.